Good morning again. Let's do solving problems from chapter 1 and from chapter 2 in this morning. Question number 3. What are the following Fahrenheit temperature in SI units? A 0 degree, B 7 degree, C 98.6 degree. We'll do for 3 questions. Hence, the SI unit of temperature is Celsius. 32 degree Fahrenheit is equal to 0 degree Celsius. 212 degree Fahrenheit is equal to 100 degree Celsius. Solution. A. This conversion is a bit more complicated than most since 0 degree Celsius is different from 0 degree Fahrenheit. Look at carefully and follow me. You need to use a conversion formula which is easy to figure out. Then here just for a fun, you can just grab the formula out of the book and skip all this if you want, but then your life will be just that much less interesting. The formula should be this from like a conversion factor with an offset to match up the zeros. A into degree Fahrenheit plus B is equal to degree Celsius. B matches up the 0. A scales everything to Celsius. We know that 32 degree Fahrenheit is equal to 0 degree Celsius, 200 degree Fahrenheit is equal to 100 degree Celsius. Plugging this into the formula to get A and B, A into 32 degree Fahrenheit plus B is equal to 0 degree Celsius minus 32 degree Fahrenheit is equal to B. A into 212 degree Fahrenheit plus B is equal to 100 degree Celsius. A into 212 degree Fahrenheit minus 32 degree Fahrenheit is equal to 100 degree Celsius. A into 180 degree Fahrenheit is equal to 100 degree Celsius. A is equal to 5 over 9 degree Celsius over degree Fahrenheit. So the formula is degree Celsius is equal to 5 over 9 into degree Fahrenheit minus 32 degree Fahrenheit. Then 5 over 9 degree Fahrenheit minus 32 degree Fahrenheit is equal to minus 17.8 degree Celsius. B 0 degree Celsius. Degree Celsius is equal to 5 over 9 degree Fahrenheit minus 32 degree Fahrenheit. 5 over 9 into 72 degree Fahrenheit minus 32 degree Fahrenheit is equal to 21 minus 21.1 degree Celsius. C degree Celsius is equal to 5 over 9 degree Fahrenheit minus 32 degree Fahrenheit. 5 over 9 into 98.6 degree Fahrenheit minus 32 degree Fahrenheit is equal to 37.0 degree Celsius. Let's see number 4. The following equation describes the motion of objects in each case. What must the units be for the variable A, B, and C? Assuming x is displacement, v and v naught are the velocities, m is a mass, and t is the time. A. X is equal to a square plus bt plus c. B. X is equal to a cos into bx minus ct. C. V is equal to ax is the power of bm minus c square over b naught. D. Sin ax square is equal to b cos into ct square. Hint. Units must match on both sides of the equal sign. Units must cancel inside of a function. It is only possible to add quantities if they have the same unit. Solution. A. Here is the equation expressed in unit only. Meter is equal to a into second square plus b into seconds plus c. What we need to have is meter is equal to meter second plus meter second plus meters. So in order to this, A is equal to meters over second square, B is equal to meters over second, C is equal to meter. B Again, here is the equation expressed in unit only. Meters is equals to A cos into B into meters plus C into seconds. What we need to have is meters is equals to meters cos into unitless plus unitless. So in order to do this, A is equals to meters, B is equals to 1 over meter, C is equals to 1 over second. C, again here is the equation expressed in unit only. Meters over second is equals to A into meters is the power of B times kilograms minus 1 over meters. What we need to have is meter per second is equal to meter per second is the power of unitless minus 1 over meter. So in order to do this, A is equal to 1 over second, B is equal to B is equal to 1 over kilogram, C is equal to meter per second. D. Again, here is the equation expressed in units only. Sin A into meter square is equal to B cos into C times second square. What we need to have is sin times unitless is equal to unitless times cosine into unitless. So in order to do this, A is equal to 1 over meter square, B is equal to unitless, C is equal to 1 over second square. Number 5. Given that the mass of the proton is 1.67265 times 10 raised to minus 27 kilogram, and that the mass of an acceleration is 9.11 times 10 raised to minus 31 kilogram. A. How many significant figures are there in the given proton mass, the electron's mass? B. Express the mass of the hydrogen atom, or 1 proton and 1 electron, with the correct numbers of significant figures. Note, we are neglecting the binding mass. If you don't understand what that is, hint, when you are adding or subtracting numbers, the last significant digits in the answers will be in the rightmost columns where all the summed or the subtracted numbers have significant digits. Solution A. The mass of the proton is 1.67265 times 10 raised to 27 kilogram, which has 6 significant digits. The mass of the electron is 9.11 times 10 raised to minus 31 kilogram, which has 3 significant digits. Solution B. Line up the decimal points and add, or don't forget to convert them to the same power of 10. 16,726.5 times 10 raised to minus 31 plus 9.11 times 10 raised to minus 31. That means 16,735.61 times 10 raised to minus 31. However, since 16,726.5 times 10 raised to minus 31 doesn't have any significant digits in the 10 to the power of minus 33 or minus 33rd place, the answer needs to be rounded to 1.67356 times 10 raised to minus 27 kilogram. Number 6, a piece of paper is measured to be 16.2 centimeter by 9.8 centimeter by 1.1 millimeter. What is the volume of the sheet? Be sure to express your answer with the proper number of significant digits. Hint: in multiplication and division, the number of significant figures in the solution is equal to the smallest number of significant figures of numbers b being multiplied or divided. Solution v is equal to x times y times z, which is equal to 16.2 centimeter times 9.8 centimeter times 0.11 centimeter. The calculator gives an answer of 70.4636 centimeter cubed. However, because the minimum number of significant figures in the number being multiplied is 9.8 centimeter, that is 9.8 centimeter, we can only carry two significant figures. Therefore, the answer should be 17 centimeter cube. So we saw these exercises and be ready to solve problems for chapter 2 next time. Until that, don't forget to subscribe in YouTube, TikTok and other social media channel. This Mame Physics Tutorial channel. Have a nice time. If you have question, comment and suggestion, write to me on the comment bar. Thank you very much.